Two cars, both of mass m, collide and stick together. Prior to the collision, one car had been traveling north at a speed of 2v, while the second was traveling east at a speed v. Neglect horizontal outside forces on the cars, such as friction from the road on the cars. Immediately after the collision, what is the speed of the joined cars? V, 2v, 3 halves v, square root of 3 halves v, or square root of 5 over 2 v. Okay, so let's call the cars car 1, which is traveling north at 2v. We'll draw a little never eat shredded wheat symbol. And then car 2, this is going east at speed v. And that's before the collision. And then after the collision, they're kind of squished together into this 1-2 mass, which is going up at some v final, which we don't know. So we know that momentum is conserved, and so final momentum equals initial momentum, but there's two components. So let's set y to be along north and positive x to be along east, and we'll keep track of the components x and y of P1. That's going to have 0x component, and it'll be going north with 2 times m times v. So don't forget the masses of both these are m. For P2, its x component is m times v, and its y component is 0. And so if you want to sum it up, this is both before, this is initial. So P initial for the whole system is going to have x component mv and y component 2 mv. And so P final equals P initial. So we have 2m is the mass of the final times v final equals the square root of mv squared plus 2mv squared. Actually, what we're doing here is we're equating the magnitude of the final momentum equals the magnitude of the initial momentum. The initial momentum is a vector with, this is the x component and this is the y component. And so the magnitude of, this is p initial x and this is p initial y. Magnitude of p initial is equal to the square root of p initial x squared plus p initial y squared. That's Pythagoras. So squaring both sides of this equation, we have 4m squared v final squared is equal to m squared v squared plus 4m squared v squared. There's an m squared in every term, so we can divide both sides by m squared. And then we'll also add these two, so this is still 4v final squared is equal to v squared plus 4v squared, so that's 5v squared. We're solving for v final, so I'm going to divide by 4. So v final squared is equal to 5 over 4 v squared. And then I'll take the square root of both sides, and we'll say v final is equal to plus or minus the square root of 5 divided by 4 times v. And since these are speeds, we'll choose the positive solution. Speed is greater than 0, so choose a positive solution. And so v final is equal to, the square root of 4 is 2, so it's square root of 5 divided by 2 times v. So that is solution E. And square root of 5 is going to be a little greater than 2, so because square root of 4 is 2, so this is something a little greater than 2 over 2, so it's a little greater than v. So you've got two cars going in perpendicular directions, and one has speed 2v, one has v. They collide together, and their final velocity is greater than v, but it's less, quite a bit less than 2v. That sort of seems to make sense.